All right. Hello, everyone. Good to have you here. So some of you know me, some of you I haven't met yet. I'm Daniel. I work at Broadcom in the Spring and Tanzu org. So in the Spring org, I do Spring framework things related to security, Spring security, authorization server, LDAP session, these things. And then in the Tanzu org, I do applied Spring. So we take Spring, we build products with them, and then we ship them to customers. And we ship them in the Tanzu application platform, which is packaged and distributed with the Carvel project. So as such, I am a user of Carvel. You can find me on the web, links, email, reach out. It's always fun to interact. I'll give you that at the end again. So before we get into the technical details of Carvel, a little disclaimer. The font size is all right, yeah. This is an overview. So Carvel has 7 tools. So if I take 7 minutes per tool, it's the entire talk. So I won't be showing all the tools, and each tool I will not be able to go super, super deep in everything, so it's going to be partial in some ways. There's a lot of content. Sometimes it may be a bit fast, which is fine. I don't need you to remember all the things that I type. The idea is more to give you, an overview and maybe a little bit of appetite to go and check by yourself and see if you would like to use this. And this presentation is more from a developer perspective, so I'm more of a Java guy than an SRE ops person. So, this colors the presentation a little bit. I don't do YAML all day. I mostly do Java all day. So this is more a user type of presentation. So on the menu today, we're going to take a look at what this Carvel project is. And then we're going to get into a demo and build an application with Carvel. So, build some YAML, deploy it with a kapp tool, and then make it production ready, package it, distribute it, and do a little bit of a GitOps at the end, package management with the kapp controller, and see how developers can consume the packages we make. So Carvel is a CNCF project. It's been in Sandbox for 2 years now. On the website, in the description, they say Carvel provides a set of reliable, single-purpose, composable tools that aid in your application building, configuration, and deployment to Kubernetes. So application building, configuration, deployment, it's basically make some YAML, configure the YAML by changing some values, and then push that to the Kubernetes API server. The more interesting part is the philosophy of the beginning, the reliable, single-purpose, and composable. So reliable is the aspect that we want to be pushing immutable references of things to our cluster. So we want to know what we're pushing, and we want to be sure that it doesn't change over time, so that we're sure of what's deployed. Single purpose and composable, they go together. So some tools like Helm, they take the whole problem space of deploying to Kubernetes, and they make one tool to do it all. Carvel, on the other hand, it takes the different problems you have when you want to develop or publish apps to Kubernetes, and it splits these problems into small chunks and makes one tool for one problem. So there's a tool for YAML templating, there's a tool for deployment, there's a tool for packaging, there's a tool for GitOps, and so on, and they're separated. So you can take any of those and put just that one tool in your toolkit because it fits your use case. You don't need to adopt the whole suite. But these tools, they're composable. So when they're built to work well together. So following the Unix philosophy a little bit. So I can take YTT to template some YAML, pipe the output into kbuild to resolve images, and then pipe the output of kbuild into kapp to deploy it, or like use kapp controller to wire all these tools together and make a single solution. And so if you want to discover a little bit more about Carvel, there's a website. So here on carvel.dev, here are the 7 tools of Carvel. So we have 2 that we will not cover today. So Vendor is a tool for syncing dependencies on your laptop. Think of it as Git submodules, but it also works with HTTP, with GitHub releases, with Helm charts. And so you do vendor sync. It downloads the files you want on your computer, it creates a log file, and you can target specific files and know that they haven't changed. Secret gen controller is a controller you put in your cluster to generate secrets. So if you need a password, if you need an RSA key, if you need a certificate, you can use secret gen controller for that, and you can also use it to manage secrets. So copy secrets from from a namespace to another, but only some parts of a secret. We're going to focus on all the other tools, the other 5 here, and build an app with that. So we're going to start with YTT. So YTT is a YAML templating tool. It allows you to write programs in YAML, and a YTT program is a valid YAML file. So your program is actually written in the comments of the YAML file. It outputs another valid YAML file. It cannot output something that is not valid YAML. So it understands the structure of YAML. So when you compare this to Helm templates, for example, Helm templates, they do text templating. And so you have to indent stuff so that they're in the right place, because it's just producing text. YTT is producing YAML. But it's producing any kind of YAML. It's not limited to Kubernetes resources. So if you have GitHub actions that you want to template with loops and variables you want to pass in, you can use YTT because it's just YAML. So it's a good substitute for a Helm template. It has all the trappings of a templating tool. So it has variables, control flows with like loops and if statements, functions, and you can also pass values from outside. So build something with it. We're going to build this. So a standard Kubernetes deployment, right? We will have an nginx that exposes a page. The page is in a config map, and then a service and an ingress to make it accessible from the outside. And the gist of it is we want to do this, but we want to do this for apples, bananas, and strawberries. So there's going to be a for loop and some variables in here. So let's get started. In here, I have a starters, and I'll create a config file, config.yaml, from scratch. And so in here, I can do any YAML. So it doesn't have to be Kubernetes resources. I can say this is foo bar, right? And I can apply, I can pass that to YTT. I have to save it first. I can pass that to YTT, and it produces the YAML. So to build our file, we're going to watch for changes in this directory. And anytime anything changes, I'm going to run the following command. So I'm going to clear my terminal, and then I'm going to apply YTT, take all the files in here, apply YTT to them, and then pipe that into YQ so we have a little bit of coloring, right? So if I change this and Baz is now Daniel, it updates on the right. Okay, so we said we want 3 config maps. API version is v1, the kind is config map, it needs metadata with a name, metadata name is, say, my app, and it has data in it. So index.html, hello world. Okay. What happened? That's a lot, but okay, there we go. Okay, so we have our config map, a real config map here. And so let's try and like make it configurable a bit. So let's say maybe we want a namespace. And I said with YTT we can do a program in comments. So I can say here the namespace is going to be, let's call it boxed, right? So this is a YTT comment that is code that is going to be executed. And I can take the output of this and say namespace is this namespace variable here. And so it injects my namespace that's computed from the outside. So since this is code, I can turn on syntax highlighting to have a little bit more colors in my terminal here. And so we want this for apples, bananas, and strawberries. So we can make a for loop. For app in apples and bananas and strawberries, right? I'm going to produce a config map per fruit. So now we have 3 config maps. They're the same because I don't customize them. But now I can say this one is app, and then maybe here I can say the content is, I don't know, hello something. Format, and pass the app in here, right? So we have 3 config maps, one for apples, one for bananas, one for strawberries, with a for loop in here. This is made with YAML directly in my for loop. I can also do functions. So I can do def my config map. It's going to have a name. It's going to have, say, content, right? And so in here, I could do something like return, and return something that is a valid structure, config map, something like that. So I could do this. So if I do this, I could take that, and in here call my config map. The name is going to be app, hello, just hello plus app. It's not super interesting. I have 3 config maps. The cool thing with YTT is that in the body of my function, I can put any valid YAML. So my config map that I had from before, I can put it here and return it directly. So, and this is the content. So now we have functions. In my function, I write some YAML, the YAML that I want to output, and then it's fine. It manages to put it in my file. And what's really cool is that it knows it's a YAML structure. So if I want something to be nested and to be nested deep, I don't need to indent anything. Under nested deep, it puts the YAML content that I have because it understands the structure. So if I try and produce invalid YAML, say by indenting this, YTT is not happy. It tells me, well, this YAML, here you're trying to do both a value, v1, and a map. That's not possible, so I won't let you do this. So you have feedback early, not when you're trying to publish this to your API server. Okay, so we have control flow, we have for loops, if statements if we want, we have functions. This, I would like to have these variables, so for example, this one, this boxed namespace, to come from the outside so that people can configure my template. I can do this using a YTT module. Think of it as a library. So there's this YTT data module that allows you to pass data from outside. So in here, I'm going to say the namespace is data values namespace. So YTT is going to complain because no one is passing that namespace from outside. So if I wanted to pass the namespace, I could do YTT-F data value namespace equals Brussels, right? And so it's able to take that value, inject it in my template. This is fine when you have one value, but like if you have a bigger template with a lot of things, then it becomes complicated to pass them with data values. So instead, what you can pass is a config file. So in here, I have a data values file. It's empty for now. And I can write a YAML file in which I'm going to say the namespace is going to be Vox Brussels this time, right? And I instruct YTT to use that as the data values for the file. So if I save this, then I can pass all my variables through a config file. So for example, we can make our app configurable. So the apps here, it's an array. They have a name, apples, and then HTML. So I love apples, and we could make that for apples, for bananas, bananas, and no, maybe strawberries. There we go. Okay, and so I could use that in my config in here instead of having for app in this array that I have here, app in data values.apps, and in here it's going to be the app.name, and we're going to use the HTML app.html here. So now we have the I love apples, I love bananas, I love strawberries that are loaded from the outside, from an external file. So basically you have all of Helm template here, but you're writing code, you're writing a program that outputs this YAML. And this program, if you're familiar with Python, it should remind you of something. So these are very close to Python function definition for loops. This is because the YTT programs are a dialect of Python, which is called Starlark. And so it's basically Python without the indentation. And so you have end blocks here. A little bit smaller standard library, but you can almost anything you can do in Python, you could do it in YTT. Okay, so we have our thing here, right? I said we needed deployment services ingresses, so you don't want me to be typing this for an hour. So instead, I'm going to copy the complete config directly so that it's full, right? So I don't have to type the ingresses and so on. So that's for generating a template that your users will use to inject their values and have their things. But sometimes you get files that are from the internet, or you get a Helm chart. And you want to change one thing. You want to add labels, and there's no extension point for adding labels. So in Kubernetes, you would use Kustomize to change values. But with YTT, you can do it as well. So YTT has a concept of an overlay that you can apply. Kustomize is very data-driven. You pass it some data, and it merges the data, and you can tell it how to merge it. YTT is programming again. So using the same model, you can evolve a config. So here's the overlay file that I'm going to apply. So we could say here on the right, I have my ingresses, services, and so on. And I want to change, say I want to change everything. So overlay everything. There's going to be at least one node, fine, maybe 10. And in here, I want you to change the API version of everything to the best API version in Kubernetes, which is v1 Daniel 1, right? So in here, all my resources become v1 Daniel 1. But maybe that's not, maybe ingress is not a v1 Daniel 1. Maybe I want to change this a little bit. So in here, I could say, I want overlay.subset. I only want, say, kind config map. So just change the config maps for me. Don't change the ingresses, services, deployments. And so in that case, the namespace stays v1. Ingress is still networking cates.io. But if I find a config map in here, it is v1 Daniel 1. And since this is programming, I can make variables, and I can do basically anything I want in here. So if I take that, and paste it here, we're going to call this CM for a config map. So CM here. And so I could tell YTT to do overlay match by the opposite of a config map. So anything that is not a config map, take it, CM, expects 1+. So everything that's not a config map, you take it and you remove it. Please delete it from the file. There we go. And so here on the right, it just keeps the config maps. It removes everything that is not a config map. And since this is programming, you can do all sort of crazy stuff, right? You could define functions, so like alternate, existing text, nothing. Result is an empty array, and then for I character in enumerate of the existing text, and take the existing text, and then I'm going to make it like have some weird casing. So if it's an even character, if the character is 0 or 2 or so on, I'm going to append I dot upper, say, oh, not I, char dot upper, so uppercase. Else result append char dot lower, right? Make it lowercase. End, and return. Oops. What do we want? Join the results into a string in the end. So this function, and here, make everything a YAML program like this. And so now in my config maps, I can use that and say in data, you're going to take index.html, and then you are going to replace via this alternate function, alternate, there we go. And so it takes the existing content in the YAML, and then it applies a function to it, which is going to take the letters, and every other letter is going to put it uppercase, and every other, and the odd letters, they're going to have them lowercase, which is not something you can do with Kustomize. Kustomize is data in here. So if you have, say, a deployment that has a config, and in a config map that is there's some text, and you want to replace some of that text, you can use that, and it will just change that little thing. And you use regular expressions. You can do a lot of crazy stuff. Okay, so YTT, YAML templating. It can replace Helm template. It can replace Kustomize. It can work with both. You can have an Helm template and then a YTT overlay to change your Helm template after. Or you can have a YTT template and then use a Kustomize patch after. So if you want to learn YTT, you don't need to be a bash wizard like I do with like my 2 terminals and so on. You can go to the YTT website. And at the bottom of the page, there's this playground with a lot of examples. So here's how you use if blocks. Here's how you use for loops. Here's a full demo. And you can change values in here. You can say, oh, well, this first here is premier, and it changes the value on the right. And maybe this one will have a port, which is 1000, and it adds the port here. And maybe also there's a schema. I want to apply a schema. So I can say, oh, this should be an integer, and I pass a string, and YTT is unhappy by that. So you can learn on the website, and you can also have this website running locally. So if you oops, come back. If you want to not send your data on the website, you can run YTT website, and then on localhost 8080 you have the playground. So all the examples can work on your machine too. Okay, so we have some YAML. There we go. Good, good. Now we want to deploy it. So YTT, great, produce YAML. To deploy it, we could use kubectl. So by default, with Kubernetes, you use kubectl. But you can have problems. Let's remove this overlays here. YTT, our entire directory here. So in here, in this example, I make an ingress service, and they're all in the Vox Brussels namespace. And the Vox Brussels namespace is also in my config, but it's at the end. And if you've ever done this with kubectl, you know that kubectl doesn't really know. It just follows the order of the things you give. So trying to apply this with kubectl, if I apply this, kubectl apply f dash, the namespace is going to succeed, but everything else should fail. Because when we try and create the service, the namespace is not here yet, so it fails, right? So only this Vox Brussels succeeded. Only the namespace succeeded, so delete that. Instead, what we can use is use kapp, which is a friendlier way of using kubectl and deploying stuff. So the idea is that kapp knows what you're trying to do when you deploy a set of resources. It has a concept of an app, so it's going to group the resources together so you can find them in your cluster. It knows how to order things and how to wait for things to be ready. Right? So because if I apply a deployment on Kubernetes, it says, yes, it's applied, and I have to write my own wait rule on top of it. Kapp does the waiting for me. So if we do an example here, take this file that I had before, this with the namespace at the end, and instead of doing kubectl apply, we do kapp deploy, and we give it a name. So this app is going to be called Vox, for example. Files come from standard in, and I say yes to avoid interactive prompts. So when I apply this, we can look at what kapp tells us. Zoom out a little bit. So first it tells us everything that it's going to apply in my app. And if there are changes, what changes are going to be applied. And then it applies the things in a reasonable order. It knows that namespace must be present for the other resources to be there. So first it applies one change, which is creating a namespace. Once the namespace is ready, it's going to create the config maps, because it knows config maps will be mounted into deployments. And so we want the config maps to be present for the deployments to succeed. And then once the config maps are created, it creates the other resources. And then it waits. It says, well, you told me to make this deployment and put it on your cluster. I know when a deployment succeeds. It's when the status becomes ready. So it knows it can wait. Oh, I'm going to wait on the replica set when waiting on the pods. So it takes a few seconds, about 3 seconds, and after 3 seconds, my 3 deployments have reconciled, and now kapp tells me I succeeded. I deployed your app, and everything is good. So now if I go in here and I try and go apples, here, I love apples has been deployed. So since this is an app, these resources, they're together in the cluster, and kapp helps me find them. So I can list the apps. I can say, hey, what apps do you have here in this namespace? Well, I have the Vox app, and I also have this Carvel demo. I can find all the apps in in my cluster. So I have some infrastructure that I deployed with kapp. So I don't need to track the files to remember all the things that I put together. It's already in my app. I can inspect the app. Inspect the app I called it Voxed, I think. Right? And so here are all the resources that are linked to this app. And now, of course, I can delete an app if I want, right? Kapp, delete, and then the app is called Voxed. And so it tells me, are you sure you want to delete all of this? Deletes everything, and it waits smartly. It knows, okay, I want all the things to be fully deleted to say it's good. With kubectl, there's also another thing that's a bit sometimes annoying is I have a config map, and I change it. So let's reapply this app to see the difference. So I have a config map, I change it, I change the config map, I apply it to the cluster, but my deployment doesn't know it has changed. And so the value stays the same. So if I take my data values here and I change I love apples to j'aime les pommes, yum yum, right? If I reapply this, it changes the config map, but the deployment, the Kubernetes deployment, doesn't know the config map has changes. With kapp, I can tell it, this config map is going to change, you should care about it. So in your config in here, you can control some of the way these resources are applied with annotations. So I can add an annotation to my config maps and say kapp k14s.io, this is the annotation, is versioned. So when I do this, I'm going to apply it so that it takes that into account, right? So now, if I change my data values and the strawberries, I'm going to say change and les fraises c'est délicieux, right? If I apply this, I'm going to tell it diff changes, so it shows me the changes in details. If I do this, it tells me your config map strawberries, I change the value I love strawberries to les fraises c'est délicieux. But also, I change the deployment. What I'm actually doing with this config map, I'm creating a new version of it. There was a version in the cluster, and I create version 2. I change your deployment to point to the version 2, and so then the deployment updates. And so it's aware of the changes. So in here, if I do strawberries here, it takes the latest value that I have in my file. Les fraises c'est délicieux. Okay, cool. So we saw ordering of resources. You have, namespace comes first, config maps, but you can write your own ordering, if you will. I'm going to delete the app. Yep. So sometimes you get given Kubernetes deployments, and they should be eventually consistent, and they should not really care about the ordering too much. But in real life, sometimes it's important, the order in which they're applied. So in here I have an example with eventual consistency. So if I kapp deploy, I'm going to call it consistency, all the files that I have in here, it's 2 deployments, a DEX, which is an identity provider, and OAuth2 proxy. If I deploy this, it deploys everything, and if I go and look at the pods in the default namespace, the first deployment succeeds, but the second is an error here. That's because the second pod is trying to talk to the other deployment and says, oh, I can't find the route to this other thing. So eventually, after 2 restarts, the first pod, the DEX pod, is on, and so eventually this reconciles. But with kapp, if I delete this consistency app, yes. With kapp, with annotations, I can control the order. So I can do that myself. In here, I can take my DEX YAML here. It has an annotation. The DEX deployment has this annotation that says, oh, this is the DEX change group. The OAuth2 proxy has its own annotation. This is the OAuth2 proxy change group. Well, apply this only after you've changed the DEX change group. So upsert after upserting DEX. So it applies this after the other one has successfully reconciled. So if I kapp deploy again, right? So in here, First, it reconciles DEX. And once DEX has reconciled, then it applies auto proxy. Only when DEX is ready, it applies the other one. And so now this one, it goes online with 0 restarts, which might be interesting when you have very complicated apps. You say, oh, I want to deploy this controller that's going to create some custom resources. I wait for the custom resources to be present to be able to then apply them. And you can have multi-stage deployment with kapp. So truly, if you're hacking locally and you're deploying stuff with kubectl, it's a great benefit to just like do away with kubectl and use kapp instead, because it's a drop-in replacement. You just kapp deploy -f, and then it deploys your files. Okay, so we can make YAML, and then we can deploy it locally when we're hacking and when we're iterating. Now, that's still very local deployment. We're not trying to make something that's very production ready. When we do stuff that's production ready, for example, when we produce the Tanzu application platform at Broadcom, there are things that we don't want to do. So for example, here's a config, and it uses Nginx. And we use a tag for Nginx. We say, oh, we're going to deploy this app with like Bitnami Nginx 125.2. There's no guarantee that this tag has the same image tomorrow. Right? Someone can re-push to Docker Hub a new version of Nginx under the same tag. And so tomorrow, if I reapply this, I may get something different on my cluster. So in order to avoid this, we can use the tool that's called kbuild. Kbuild is going to take your YAML files, is going to look for anything that looks like an image, and it's going to resolve the SHA so that you know the exact reference of the exact content of that image. So in here, in this directory here, I can apply kbuild on config. So if I do this, it talks to Docker Hub, and then it finds, okay, yeah, I had Bitnami Nginx 125.2. I replace this 125.2 with the actual SHA reference. So now I know what I deploy. So I could take this file, this templated file, and put it in source control if I want to lock it at some point. But with kbuild, I can also, instead of changing the whole file, I can produce a log file. So I can say image package log output, put it under image packet images.yaml. So it's going to do the same. It's going to do the same output, but it's also going to produce this log file, which I can independently commit to my source repository. And this log file basically tells if someone is looking for Bitnami Nginx 125.2, they could use this SHA reference instead. And so now, when I apply kbuild with this, I can pass the image package images file, and it resolves instantly because it doesn't need to translate from Docker Hub. It knows how to translate Nginx 125.2 to the correct SHA locally with all my images. Okay. So kbuild to stabilize my config, and now I want to distribute it. So I could commit this in my Git repository and use GitOps in my cluster. There's another way to do these immutable configs that I can reference with a SHA, and it's to put these files inside a Docker image, an OCI image, but that's not running. And so it's not an executable Docker image. It's just packaging the files and pushing them, instead of a Git repository, pushing them to a registry. And you do that with the image package tool. So image package, imagine it's the tar and FTP, but instead of FTPing to a server, you're FTPing to an OCI registry. So it takes all your file that you want to put in a bundle, and it makes a non-runnable OCI image, and then you can push it to a registry, and you can pull it from a registry, which allows you to do, instead of GitOps, do registry ops. It has the advantage of like having these immutable references, but also, since it's in a registry, your cluster should be able to pull that config easily without Git credentials, right? You're already pulling images from the registry to deploy them, so you should be able to pull this config. So a demo of this, we can image package push a bundle, Call it, I don't know, localhost vox 5000, my local registry, voxed Carvel, and then we're going to call it demo. And then the files are everything in here. So it takes all the files on my local machine, and then it pushes them to a registry. If I want to download them, I can now in this directory do image package pull the bundle that's called localhost 5000. I call it voxed Carvel demo. And then the output, I'm going to put in a directory called out. And so if I look what's in my out directory, it pulled all the files, and then it put them locally, and I can use them, including this .image package images file. Why is it called image package? Because image package allows you to do one more thing, which is relocating, copying your application from the public internet to your private registry. So we have customers with Broadcom that are like the Ministry of Defense, and they have a data center that does not have access to the internet. So they cannot pull Alpine from Docker Hub. When we ship them the Tanzu application platform, we do it with image package. They are able to take this bundle and copy all the dependencies for it in their data center in one command. So they do image package copy. They use the bundle, so the pull we did here, right, this demo, in here, instead of pulling it, they're going to do copy, and then to repo another, their local, kind registry, local, so it's a different registry, 5000, voxed Carvel, right? And so this image package is going to download these files, and then it's going to notice, oh, you have an image package lock in here, and it references Nginx. So I'm going to go and fetch Nginx and then copy it to your cluster so that you can download it from your cluster without having to resolve it from the internet, without having to go to Docker Hub. And so when a customer downloads and installs the Tanzu application platform, they will get like our 80 images. And how does that work? Well, basically this bundle that we copied in the kind registry here, if we pull the bundle, Carvel, demo, and then output, we put it in relocated. It's going to, in relocated here, in the image package image lock, it will have created a new image lock, which says Nginx 125.2 is not on Docker IO anymore. It's on your kind registry local voxed Carvel. It's now this image that I pushed under that name. So when you apply this log file, then you will not be fetching from the internet anymore. You will be fetching everything locally. Okay. So kbuild to resolve images, image package to bundle and do these OCI ops. The last bit that we have is GitOps, or everything that is package management and delivery using a controller. So there's this controller in Carvel that's called kapp controller, and it does everything that you would need to do for GitOps. So basically it gives you a resource that's called an app, and this app resource has the 4 things you need for GitOps. It has where do you want to deploy your things. So do you want to deploy to another cluster, or do you want to deploy to the local cluster but with scope down permissions? It has the second bit, which is what do you want to deploy. So how do you get your config? Where do you get your config from? And you can have it from different sources. So it can be, a Git repository. It can be over HTTP. It can be an image package bundle. I can download the files from image package and then use these config files to apply an app. It can be a Helm chart, so it's compatible with Helm. We can pull Helm charts and then apply that to your cluster. So where, what, how do you configure it? The template phase is, do you apply YTT to it? Do you apply kbuild to resolve images? Do you apply Helm template to put values into your Helm templates? And we support also queue and subs. So you have your files, you know how to change them, and then how do you deploy them? You can deploy them with kubectl or with kapp. After all, it's called kapp controller, so we're using kapp to deploy. So an example of this in appcr here, right? So here's an app, a kcontroller app. I fetch the files from the local registry. So I'm doing registry ops. Then I template them to with YTT using some values, and I want the values to be in my cluster here, so in a secret. So I have a secret in here that's going to deploy like this POM application instead of apples. It takes them in the cluster. And I also apply Carvel to pull the right images and so on. So, okay, if I apply this, I could apply it with kapp. I don't have to. I can apply it with kubectl-f, apply-f, the app here. So if I apply this app, I have an app that's created here, and kapp controller reads it, downloads the files, and then creates all the resources for me. So I have a demo app here. I have a POM pod, so I should be able to access POM and go and have manger des pommes. Okay, let's delete it. kubectl delete -f app. So that's fine, right? It's GitOps and something you would do, or registry ops, something you would do if you're an operator. But I'm more of a developer persona, and our customers, they're more like developers. So we want to give them a better or an easier API so that they don't have to understand all of Kubernetes to have this working. And so kapp controller also comes with a CLI, which is called kcontrol. And with kcontrol, as a developer, I can discover what's available for me on the cluster, what I can install, and how I can install it. So under the hood, it's all Kubernetes resources, but as a developer, I don't need to see this. So the way this thing runs, if it wants to delete my thing, yeah, fine, whatever. So the way this thing runs is I can do kcontrol package available list, right? And so it tells me, oh, what are the packages you can install in your cluster? Well, you can install Cert Manager, and your administrators also deployed this Carvel demo that you can install. Oh, but what's this Carvel demo? What's this package? Tell me more about it. So kcontrol package available get, the package called carvel.garnier.wf. Okay, what's this package? Well, it's the Vox Brussels Carvel demo. I have a description that tells me, oh, it's a cool app to showcase Carvel at Vox Brussels, and there's one version available. Okay, cool. So, but how do I deploy it? What are the values that I can supply? Well, I can do. Okay, I have the version which is 1.0.0. Tell me what's the value schema for this. How can I configure it? Well, I can configure it with an apps key and a namespace. And namespace is a string, and it allows me to set the namespace and so on. And so I have a values file already here, values.yaml. So the same kind of a file we had before from the app we developed with YTT. So it has a namespace that has a list of apps. And now I can kcontrol package install the package that's called carvel.garnier.wf. The version I want 1.0.0. I'm going to give it a name when it's deployed. So maybe call it Voxed demo. And then I'm going to pass some values file. So it's called values.yaml, right? And so as a developer here, I'm not writing any YAML except for the configuration. I write the configuration, value file, there we go. I write the configuration, and then with the kcontrol app, I can talk to kapp controller, which is basically going to do what the other tools do, right? So they start by fetching the resources from this image package bundle. And then it's going to deploy. And how does it deploy? Well, it deploys with kapp, right? I recognize what's from kapp here, so it applies the changes and so on. And so hopefully, if I reach the end here, I could go to strawberries, and it says, yeah, right, so I have my strawberries, I have my apples, I have all the apps deployed without having to write any of the YAML. I'm just a consumer of that package. Under the hood, it's just creating these resources. So there's a package install that's created for me. So if I wanted to do GitOps with this, I could create this package install, apply it to the cluster, and ultimately it reconciles into a app. So this app here, this Vox demo app, is the thing that I just deploy with kcontrol. So it's composed all these tools together, and with my single CLI, I was able to deploy them. Okay, that's it. We've gone through everything. Thank you for your attention. If you want to access the code for this demo, it's in our repository. I have a feedback form, but I think it's the wrong URL. If you want to give me feedback, use the app. We are available on the Carvel channel on the Kubernetes Slack, on Twitter as well. And if you have questions, if you want to start using something, oh, YTT is cool, I want to use it, but I don't really understand, you can contact me here. I'll take the time to answer. Thank you for your attention, and if you have any questions, we can go over that.